Good morning, children. So today we are going to start a new chapter, chapter 12. It is all about similar triangles. Okay. So in this chapter we will discuss and we will try to learn those conditions with the help of which you can say that triangles are similar to each other. Okay, suppose you have been given two triangles and you are asked whether the triangles are similar to each other or not. So just by looking at them you cannot say they are similar or not. Okay, but if you have the knowledge of the conditions, okay, which confirms the similarity of given two triangles, then you can easily identify and you can say that the given two triangles are similar to each other. So firstly try to understand what do we understand by similar triangles. So in short I can say that two triangles are called similar triangles, okay, if they are same shape wise, okay, they are exactly same shape wise, not size wise, okay. Like here I have drawn a triangle, okay, and I have drawn this triangle. You can see, let's say this is first triangle and this is second triangle. Clearly the first one is bigger than second one, okay, so size wise they are not same, but it may happen that shape wise they are same, okay. Like you stand in front of mirror, okay, so the image that you see, okay, the image that you see in the mirror will not be same as your size, okay. Let's say you are 5 feet, then it's not necessary that the image formed in the mirror will be also 5 feet, okay, but you can say that that image is similar to you. Yes, so similarity is all about same shape, okay. So in this chapter we will be talking about similarity of triangles. So what you will do is you will give heading as similar triangles, or you can write similarity of triangles, then you will write this similar triangles, and then you will write this definition: the triangle ABC and triangle DEF are said to be similar. So here I am trying to say that two triangles are said to be similar. And when do we say they are similar? If their corresponding angles are equal and the corresponding sides are proportional, okay. So let's say I have one triangle, this is A, B, C, here it is 30°, here it is 70°, and here it is 80°. I consider another triangle DEF. Let's say this is 30°, this is 70°, and this is 80°, okay. So here you can see triangle ABC and triangle DEF, okay. So angle, you can see they have equal angles, okay, like here 130 degrees, so there also 130 degrees there, like here 70 degrees, so here also we have 70 degree, 180, so 180 is there, okay. But still we cannot say whether they are similar or not, okay, because when do we say two triangles similar? If their corresponding angles are equal. So let's say corresponding angles are equal, 30, 30, 70, 70, 80, and the corresponding sides are proportional. So corresponding sides have to be proportional. So like if you consider the triangle ABC, so if I take side AB, so side AB over here, contains which two angles? 80 and 30. So corresponding side of AB, okay, in triangle DEF will be DF. Okay, corresponding side of AB will be DF. Okay, so these sides have to be proportional. Let's say this is 8, okay, and this is 24. Now here you can see in triangle ABC, side AC has 80 and 70, okay, angle 80 and 70. So corresponding side of AC in triangle DF will be this DE. So let's say this is 7 and this is 21. Now here see side BC. BC contains 30 and 70. So corresponding to BC, okay, in this triangle will be this EF. Let's say this is 6, okay, and this one 18. Now what we observe over here, that for triangle ABC, okay, corresponding to side AB, okay, corresponding to side AB, here we have DF. So AB upon DF will be 8 upon 24, that means 1 by 3. Then you can see in triangle ABC for side AC, corresponding side, okay, here it is DE. So we can write AC upon DE, and here we'll get 7 out of 21, that is again 1 by 3. Then you see BC is there, and corresponding to BC, here you have EF. So you write BC upon EF. So 6 upon 18, again 1 by 3. So now we can say that these two triangles ABC and DF are similar. Why similar? Because corresponding angles like 30, 30, 70, 70, 80, 80, and corresponding sides are proportional. Like corresponding sides, you can see ratio coming same. Yes, 1 by 3, 1 by 3, 1 by 3. So that's why we say they are proportional. Okay, so in that case we will say that these two triangles are similar. Okay, so what you are supposed to do is you will write down this: triangle ABC and triangle DEF are said to be similar if their corresponding angles are equal and the corresponding sides are proportional. So here I have taken two triangles, you can see ABC and DEF. Okay, so here corresponding angles A, D, B, E, C, F. So A has to be equal to D, B has to be equal to E, C has to be equal to F. Okay, and the corresponding sides, like you can see this, let's say this is X, this is Y, this is Z. So since this has been marked like this and here also marked like this, that means these two angles are same. So I can write X, Y, Z. So you can see AB, side AB contains which two angles? X and Y. And here you can see which side contains X and Y? DE. So we say that AB, okay, and DE are the corresponding sides. Okay, so that's why we have written AB upon DE. Then corresponding side for BC will be EF. That's why BC upon EF. And corresponding side for AC is DF. So AC upon DF. Okay, they are proportional. So you will get common value K. Okay, like here we saw that AB upon DF 1 by 3, AC upon D 1 by 3, BC upon EF 1 by 3. So here you observe that AB upon DF is equal to AC upon D equal to BC upon EF is equal to 1 by 3. So this is only, in general we denote by, one second, in general we denote by k. Okay, so you'll write this, and once these conditions, okay, okay, are satisfied, then we say that the given triangles are similar, and this is the symbol for the similarity. Okay, so when you write one triangle over here, then you give this symbol and then the other triangle, so it means that this triangle is similar to this. Okay, so this is read as similar to. Okay, this is how we write. This is okay, this is the symbol. Okay, so you will pause the video and you will write down this. Okay, now let us see next. Okay, so we should have some formula, you can say, or condition which should confirm that the given triangles are similar. So altogether there are here how many? 1, 2, 3. Altogether we have 3 conditions. Okay, we have altogether 3 conditions, or you can say axioms. So if you are given 2 triangles and you see that any of the 3 conditions are satisfied, okay, then we'll say that the triangles are similar. Okay, so first condition is that if you see that the given 2 triangles are satisfying this axiom SAS, then we'll say that triangles are similar. Now what do we mean by SAS? So S means side, A means angle, S means side. So if you have been given 2 triangles, okay, there you see that side, one side, okay, is proportional to its corresponding side, then one angle equal to its corresponding angle, and then one side which includes angle, okay, is proportional to the side. So let us see actually. Suppose you have got 2 triangles A, B, C, D and D, E, F. So these 2 triangles can be similar to each other by this axiom if one angle, like here this angle, if it happens to be that this angle is equal to this angle, and this side, okay, this side proportional to this side, and this side proportional to this side, then we can say that these 2 triangles are similar. So if in triangle ABC and triangle DF we have angle A equal to angle D and AB proportional to D and AC proportional to DF, then we say that these 2 triangles are similar. Things will be more clear when we see questions. So here I have taken one example. Okay, so you will write down this in your maths copy. So let's see an example. Here you can see I have taken triangle ABC, okay, where this angle B is 60 degree, this side BC is 5, okay, I haven't taken unit, and this side AB is 4. And another triangle that I have taken is DEF. Here you can see angle E is 60 degree and side EF is 10 and side D is 8. Now here what do we observe is, here angle B 60, angle E 60. So here we got angle B is equal to angle E. Done. Then what we observe is, here it is 4 and here it is 8. So 4 by 8 is coming half. Okay. Here we can see it's 5 and here it's 10. So we see 5 by 10 is also half. So here what do we observe? That this AB, okay, is proportional to this in fact you can say the corresponding side which include this angle are proportional. Okay, So here what we observe is that AB upon DE is equal to BC upon EF, equal to half. So you can see here side angle side condition is satisfied, okay, because this AB and DE, you take the ratio half, BC and EF, take BC upon EF, so you are getting half, okay. And one more thing, like you should remember that here I have considered sides from this triangle in the numerator. So all the time you have to take sides of this triangle in the numerator, okay. And angle B and angle E 60 degree. So these two triangles are similar due to this condition. Side angle side means sides are proportional, which include this angle, okay. So you are supposed to write down this example in your copy, okay, then you will understand it better way, okay. So same thing is written over here, okay. So in triangle ABC and triangle DEF, we can see that angle B is equal to angle E, that is 60 degree, okay. Then we observe that AB upon D is equal to 4 by 8 equal to half, and BC upon EF equal to 5 by 10 equal to half. Therefore AB upon DE is equal to BC upon EF equal to half. So what do we conclude? That the given triangles, okay, are similar to each other due to what? Side angle side axiom, okay. See second example, okay, for that only side angle side. So here what do we observe? That we have got two triangle PQR and ABC. So here you can see that angle Q is 90 degree, angle Q is equal to angle B, okay, how much? 90 degree. And here you can see that corresponding sides here, like this is 2 and this is 3, so you can easily find what would be this side. Yes, this will be how much? 4. And here this is 12 and this is 8, okay. So using Pythagoras theorem you can easily find what would be this. So 144 minus 64, so here 0 and here, okay. Or instead of doing that, what you can do is, already sides are given, okay, so corresponding sides are given to you. So PR is how much? 3. So corresponding to PR is what? AC. So 3 by 12, that is 1 by 4. And RQ is how much? 2. Corresponding to RQ is this AB. So 2 by 8, 1 by 4. So therefore they are similar, okay, by side angle side. Clear? Okay, so or in this this would have been better to, it would have been better to do it this way. Like here using Pythagoras theorem, this will be root 5, okay, and this will be root 80, that will become 4 root 5, okay. So now you can see that the sides which include this angle are AB and BC for this, and RQ and PQ, okay. So you can easily see that angle Q equal to B, and then RQ proportional to AB and PQ proportional to BC, okay. So that way these two triangles are similar, okay. Now let's see the second condition, okay. So as I said, when you are given two triangles, you have 3 conditions with you. Now out of those conditions, if the given triangles satisfy any one of them, okay, then we say that triangles are similar to each other. So second condition is this, angle axiom, or you can say angle axiom. So if you see that in a triangle, okay, in given triangle, let's say triangle ABC and DEF, that if you see that three angles, you can see that that all the triangles are equal, okay, then we say that they are similar. Like let's say here this is 30, here it's 40, okay, and here you say 40 and here 30. So in that case these two triangles will be similar. Why? Because here 30 30 40 40, okay. So done. See example, like here 30 40 30 40, okay, similar, because we can see two angles are equal. So we'll write that in triangles angle B is equal to angle E, angle A is equal to angle D, then this. Now you see example 2, like here one angle is 70, one is 45, okay, here you can see 45 70, okay, so they are equal. Clear? Sorry, they are similar. Now third condition, when we can say that the given triangles are similar, that is side side side, means the corresponding sides must be proportional, okay. So if you have two triangles, triangle ABC and DEF, then we say that the given triangles are similar, okay, if the sides are proportional, okay. So here triangle ABC and DEF. So if it happens that AB is equal to D equal to AC upon DF equal to BC upon EF, then we say that triangles are similar. Let's see example. Like here you can see I have taken on two triangles ABC and DF. Here AB is 3, AC is 5, BC is 2. Here D is equal to 4, DF 10, EF 6. So here what do we observe, that this BC, okay, is 2 and this EF ED is 4. So 2 by 4 is coming how much? Half. And here we observe that AB is 3 and EF is 6. So 3 by 6 is half. And then AC is 5 and DF is 10. So 5 by 10 half. So here we observe that AB upon EF is equal to BC upon DE is equal to AC upon DF is equal to half. Yes. So therefore these two triangles are similar. Why? Because of side 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 axiom, okay. So here in triangles, triangle ABC and DF, we have observed this. Clear? And thus this, and therefore triangles are similar, okay. So till now we have discussed what is similar triangles. So when do we say triangles are similar? When corresponding sides are proportional and corresponding angles are equal. Now we have, after that we saw three conditions, okay. First one was side angle side axiom. By this axiom you can say the given triangles are similar when you see that sides including one equal angle are proportional. Then second condition we saw that angle angle angle, okay. We say that given two triangles are similar if you could see that two angles are equal. Third one, side 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 axiom. We could say that two triangles are similar if all the sides are proportional, okay. So these three conditions are important and you should understand, okay. And whenever two triangles are given, you should see that out of these three, which condition, okay, which condition is satisfied by the given triangles. Okay, if you are able to prove that that the given triangles are satisfying any one of them, then you can easily say that triangles are similar to each other. Okay, now let us see next. Okay, next we have, this is very important theorem. This theorem is called basic proportionality theorem. In short, I am writing BPT. Basic proportionality theorem, in short BPT. So this theorem says that if you have a triangle, okay, if your triangle, let's say A, B, C, it says if you have a triangle ABC, okay, and what you do, from you draw any parallel line, okay, like let's say I draw this parallel line to BC, okay, I'm drawing a parallel line to side BC, okay, and this is how you have to draw. You don't have to draw outside, okay, you don't have to draw outside, okay, you are supposed to, you can draw, like if you have taken a triangle ABC, then you can draw parallel line, like if I want to draw a parallel line to AB, then I can draw like this, okay. If I have ABC and I want to draw a parallel line to AC, then I have to draw like this, okay. So suppose you have a triangle ABC and then you draw parallel line DE, okay, which is parallel to BC. Then in that case what will happen, AD, okay, this AD upon DB will be equal to AE upon EC, okay. So basic proportionality theorem says that if you have triangle ABC where DE is parallel to BC, then AD upon DB will be equal to AE upon EC, okay. There is no need of proof. So in this case, what will be, what we'll get by basic proportionality theory, here we can see that, this DE is parallel to AB. So here we will get BE, means this distance, BE upon EC is equal to AD upon DC, okay. Now see this one, like in this case DE, this DE is parallel to AC. So here we will get BE upon EA is equal to BD upon DC. That means this BE upon EA is equal to BD upon DC. Clear? So this is all about the basic proportionality theorem. So here you have to write down in your copy, you have to give this heading basic proportionality theorem, in short BPT, but in examination you will not write BPT, okay. You have to write basic proportionality theorem only. So in triangle ABC, if DE is parallel to BC, like I said, if you have a triangle ABC and let's say DE is parallel to BC, so in that case your AD upon DB will be equal to AE upon EC, okay. So this is the basic proportionality theorem. And one more, like here when I say this triangle ABC is there and DE is parallel to BC, so in that case we will observe that we have two triangles over here. Let me write over here. A, B, C. Now I am drawing a parallel line, okay, DE parallel to BC. Now here you consider two triangles. One triangle is triangle ABC and another one is this triangle ADE. Okay, so your AD is this one. Yes. So here what do you observe, that this angle A, okay, this angle is common for both the triangles, for triangle ABC, okay, and for triangle ADE. And then what happens, since this DE is parallel to BC, then this angle, okay, and this angle, corresponding angles, you know, and this angle will be equal to this angle, okay, corresponding angles. So what do you observe? You observe that, let me draw separately, you observe that triangle A, B, C and one triangle A, D, E, okay. So this A is common and here corresponding angles. So actually I am trying to draw this AD separately over here and this ABC separately. So here what do you observe, that for triangle ABC and ADE, that all angles equal. So out of those three conditions, one condition was that also AAA axiom, okay. If all angles are equal, then we say that triangles are similar. So here what do we get? We get that triangle ABC is similar to triangle ADE, okay. And once triangles are similar, then corresponding sides are proportional. So that means AD corresponding to AD is which one? AB. So AD upon AB. Then corresponding to DE is which one? BC. So DE upon BC. Corresponding to AE is AC. So AE upon AC. Okay. So that is why here we have written this, okay, that if you have a triangle ABC and DE is parallel to BC, then AD upon AB, AD upon AB. Why? Just now I explained over here, because this small triangle ADE is similar to the bigger triangle ABC, and then AE upon AC, AE upon AC, okay, corresponding sides are proportional, and DE upon BC, clear? And this one, what I have written over here, this is the basic proportionality theorem, which says that this AD upon DB is equal to AE upon EC, okay. So you will write down this in your copy. Now next is converse of basic proportionality theorem, means opposite of this theorem. Now what does it say? So your basic proportionality theorem says that if you have a triangle ABC and you draw a parallel line, this DE to BC, in that case AD upon DB is equal to AE upon EC. This is what basic proportionality theorem says, okay. And converse of basic proportionality theorem says that, let's say you have a triangle ABC and there is one line, this DE, such that AD upon DB is equal to AE upon EC, then this DE has to be parallel to BC. Okay, converse of BPT says that if you have a triangle such that AD upon DB is equal to AE upon EC, so in that case DE has to be parallel to BC. Okay, so I'll just show you this statement. So converse of basic proportionality theorem, if in triangle ABC, if AD upon DB is equal to AE upon EC, then in that case this DE has to be parallel to BC. So you will write down, you will draw the figure. Okay, so now see examples. Here you can see example 1, we have been given a triangle ABC and this D and E is parallel to BC. This DE is parallel to BC. So since DE is parallel to BC, so this is basic proportionality theorem. Okay, so they have also given AD to be 2, DB to be 4, AE to be X and EC to be 3. So here we can apply BPT, means basic proportionality theorem, since this DE is parallel to BC. That's why we can apply BPT. And what does BPT say now? It says that we can write AD upon DB is equal to AE upon EC. Now we know value for AD, DB, AE, EC. Substitute and you can easily get value for X, that is 1.5. Okay. Now see example 2. Here example 2, you can see that one triangle is given ABC and DE. This line is there, but they have not said whether it's parallel or not. Okay, but they have given this value AD, DB, AE and EC. Now I can easily see that, AD upon DB is 3 by 4, okay, and AE upon EC is coming 6 by 8, that means 3 by 4. So here what do we observe, that AD upon DB is equal to AE upon EC, that is 3 by 4. Okay, therefore by converse of basic proportionality theorem, okay, this DE has to be parallel to BC. Okay, so you will write down this in your copy. Okay, so clearly I have written that AD upon DB is 3 by 4, AE upon EC is 3 by 4. So thus we are getting AD upon DB equal to AE upon EC equal to 3 by 4. So this is the condition for converse of basic proportionality theorem. Okay, and therefore this DE has to be parallel to BC. Clear? Okay children, now we will see results on areas of similar triangles. So if you have got two similar triangles, okay, if you have two similar triangles, then obviously this will have area and this is also having area. So let's say area of this one is A1, area of this is A2. So we are going to see how these areas and their sides are related. Okay, how these areas and their sides are related. So the areas of two similar triangles are proportional to the squares on their corresponding sides. So just by reading this statement you will not understand anything. So you just see this. Let's say this is triangle, okay, this is triangle ABC and another triangle is DEF. So these are similar. Let's say they are similar. So if they are similar means what? Their corresponding sides are proportional. Okay, so you can clearly see that this angle is equal to this angle and this angle is equal to this angle. So corresponding side for BC is EF, corresponding side of AB is DE and corresponding side of AC is DF. So since they are similar, then corresponding sides are proportional. That's why we have written AB upon D equal to BC upon EF is equal to AC upon DF. Okay. Now, area of the first triangle upon area of the second triangle will be equal to, okay, this AB square upon D square, like here we have got, no, okay. So you can see in the numerator we have taken only sides of the this triangle ABC. That's why in the numerator we have to consider area of triangle ABC, okay. And then in denominator we have taken only sides of this second triangle, so down we are writing area of second triangle. So what we have to do, these sides are proportional, so we have to write area of this triangle upon area of the second, and then we have to write this only. The only thing is we have to take a square of each, okay. And this is the relation, okay. We will see few questions on this, okay. And this is all for today. So you will copy these things in your exercise copy, okay.